Hey, hi, good morning, everyone. Good morning, friends. Right, welcome back to our 30 days free short term training. And specifically, I would like to talk about this particular program. Anyhow, if you have gone through our YouTube text or YouTube flyers, whatever it might be, these particular 30 days program. Okay, so we have came up in a very different way in the sense, you know where you are going to excel in the field of AI, artificial intelligence. So, what exactly are we going to learn as part of this 30 days program? I'll quickly, explain. Then we'll dive into the concepts. Right. So, as part of this 4 weeks, 30 days free short-term training, every one of us, probably not all of us, are good at AI. Am I right? We are not aware of AI. So this 30 days program will ensure that we become zero to hero. Why did we use this caption is the modules that we're going to cover as part of this program is completely linked to artificial intelligence. So ensure that you are going to utilize these sessions in a right way and get some good skill as part of artificial intelligence. Right. So what are we going to cover? We'll be covering machine learning, the first module. Okay, and moreover this machine learning we have divided into two modules where we cover classification as well as regression. Okay, so these are the two modules that we will be covering in this week. Okay, so one module will be taught in the morning session and the other module will be taught simultaneously in the afternoon session. Okay, post understanding the concepts of machine learning, we will start learning deep learning. What are we going to learn as part of deep learning? Under deep learning, we learn neural networks, the basic important fundamental concept that is mandatory to learn any topic as part of artificial intelligence. Okay, so next to you know this DL, simultaneously with DL, we will be also learning NLP, natural language processing. Okay, so how we are going to deal with text data, all the topics will be covered as part of NLP module. So these two modules will be covered simultaneously. Okay, so first weekend, then this will be happening in the second weekend. Then, with immediate effect in the third weekend, the third week, we'll start with CV, computer vision. Okay, so where we deal with images, videos. Okay, so parallelly with CV, we'll also learn the foundations of generative AI. The foundations of generative AI. So all these topics we'll be learning within 3 weeks, week one, week two, and this is part of week three. Okay, so once if you are good at all these topics, we ensure that not only delivering the topic, we also do some kind of projects. Okay, so whatever topic that we learn as part of each and every module, we'll also complete hands-on. So we'll take a project use case and that particular project will be explained end to end. Okay, from business problem, what is the business problem, then till the model building valuation part, we'll understand with respect to each and every topic. Understood? So this process will be happening throughout this next 4 weeks. So 3 weeks, it's very clear. But in the fourth week, we will understand AI tools that are freely available in the market, that one has to be aware of this. These are freely available, but majority of us are not aware of these tools. If you are aware of these tools, AI tools, your works get simple. You need not complicate your task. You can, using these tools, your task will be minimized. Your workload, everything gets minimized, right? So this is the schedule, and I hope everyone, whoever is joining these sessions, would also communicate with their friends, so that each each one of us will get benefited by end of the sessions, right? So as usual, I'll take up all your questions at the last. Okay, so focus, and I assume I can start the sessions, right? Yes. Friends, so the agenda has been communicated, right? Yes. So the first module, as part of this week, we are going to complete the first module. It is under machine learning. We are going to learn classification algorithms. Okay, so in order to understand what exactly does classification mean, we have to understand what are the types of, you know, we have, what are the types does machine learning have, right? So come on, friends. What are the different types do we have under machine learning? Any idea? If you take, or I'll still go back. I'll go back to the basic. I hope all of you have watched my playlist on 30 days free short-term training from Python to AI. Do you remember this particular playlist? Have you gone through these videos? Yes. As part of these sessions, in these playlist videos, initially we understood the concepts of Python, then EDA, data pre-processing, okay, and two ML algorithms. One is K-means and KNN, right? So two algorithms of machine learning are also covered as part of these sessions. Why should one have to go through these sessions before joining or before understanding these modules? Is, friends, for all the applications that we build as part of AI, Python is mandatory. Okay, Python is mandatory, and we cannot take it as uh, a challenge. Python is very simple, it's easy to learn. So just go and watch the videos, the sessions on Python. you know at least you'll have a basic understanding on the topics. Then we have understood a project management methodology as well. I hope you remember. So can you tell me what is a project management methodology that we use for all the projects to build AI tools, AI applications? It's CRISP-MLQ. Good. CRISP-MLQ. What is the full form of CRISP-MLQ? Cross Industry Standard Process for Machine Learning with Quality Assurance. Right? So, what is the use of this CRISP-MLQ is? We'll quickly, recap. CRISP-MLQ is a project management methodology. It's a project management methodology which helps us to build any kind of AI application or ML applications. How many stages do we have in CRISP-MLQ, friends? How many phases do we have under CRISP-MLQ? 6 phases. Good. Can you tell the 6 phases? The 6 phases that include under CRISP-MLQ are: what are the 6 phases? Business and data understanding. Yeah, we start with business, business and data understanding. Initially, we'll understand business, then we'll understand the data, okay, followed by data preparation. Good. Data preparation. Third stage, phase one, phase two, phase three is, what is the third phase, my friend? Able to recollect? Model building. Good. So I'll probably keep it here. 1, 2, 3, 4, 5. Evaluation, deployment, and sixth one is good. M&M. M&M stands for monitor continuously and maintain it. Right. So I'll introduce again for the folks who have joined for the first time. They quickly understand why am I in talking about all these phases. Is, whatever you're going to learn as part of these sessions, we are going to use this project management methodology as part of our projects. Okay, so that is the reason I'm still going through this, project management methodology to have an overlook. Right. If you see here, initially we'll understand the business problem, then followed by the data. Once after understanding the business problem, we'll make a project charter which ensures that each and every high level documentation is present inside it. Okay, it contains objectives, it contains constraints, it contains the challenges, risk, budget, milestones, everything, each and every information. Okay, so everything has to be present inside a document. It is nothing but project. Once after completing your project charter, we also go and go through the data that was shared by the client. Okay, so whatever the data that was given by us, I mean, so we'll go through the data, we'll understand it. Okay, so sometimes depending on some projects, client may not provide the data. In that case, we have to collect the data. Okay, so once after understanding the data, we'll do some kind of preparation. Okay, so where data preparation has three subphases. One is EDA, exploratory data analysis. Then the second one is data pre-processing, and the third one is feature engineering. Right? So as part of data preparation, we'll do all these steps. We'll do analysis. Once after completing analysis, we'll get the insights. We'll share them to the client on the raw data. Then we'll clean the data. Okay. So friends, these are some mandatory steps that we do on the data initially. If you have failed to, you know, join the previous 30 days sessions from Python to AI, it's my sincere request, go and complete these sessions initially. If not, probably you'll understand the concept of the algorithms, but when you do it on a project, okay, when you do it as a project, you'll fail. We'll fail. The main reason is, we are not good at the basics, the fundamentals. So when I'll just give an example. Assume that we have learned naive Bayes algorithm today. Naive Bayes is an algorithm. Okay. So after completing understanding this algorithm, what we are supposed to do, what we have to do, we have to apply it. We have to apply this algorithm on the data set. Okay. So when you apply this algorithm on the data set, you directly go and build the model. No, right? You have to start from scratch. Understand the business problem, then understand the data. Then as part of data preparation, you have to do EDA, data pre-processing, feature engineering has to be done. Once after completing these two phases, the third phase is model building. We'll build a model using Naibase. Okay, so keep in mind, even though if you have not gone through these sessions, go and you know have a look on Python to AI sessions that were covered so far, right? Because from tomorrow we'll work on projects. For each and every algorithm that we'll do a project. I hope you got my point. Yes. So once after completing the data preparation, we'll build a model. What is a model, my friend? So this is the question that is generally asked. What is a model? What do the name says that, model building. So that it's nothing but you are going to build a model. What is a model? What exactly is a model? Model represents an equation. Am I right? See, on day one itself, I have told when I was explaining these particular sessions, a model represents an equation. In the back end, a equation like y is equals to f of x will be built, and what does y represent? What does x represent? I want everyone to respond here. What does y represent? Y represents output. X represent inputs. Okay, so when you take a use case, for example, with respect to life sciences healthcare. Okay, so in order to when a person walks in, whether a patient has cancer or no cancer can be understood. So with respect to the features, x1, x2, x3, x4, so on. I can have n number of features, n number of inputs and output. Right? So all these, using all the features, what you're going to come up with, I'll create a function. F represents function. So using all these inputs, we are going to create a function which helps us to predict y. What is the agenda? What is the main aim of building a model? This model will help us to predict the future. future for the upcoming patients. So if I'm running a hospital, or if there is a client, if you had a client who is running a hospital, okay, so this guy probably will treat the patients who have cancer aging. So the patients walk in to the hospital. Yes, when the patient walks in, what we get, we'll get the data from each and every patient. So we'll make a database, we'll make a table, we'll store it, and using this data, I'll come up with a equation. This is named as model. What is the use of this model, Akhil? Why are we, building it? My friend, you know, using this model, I can predict for the new patients. Isn't it? Yes. Have you ever observed is predicting the temper? See, for example, if you take any specific location, for example, I'll take Hyderabad. Okay, if I open Google browser and I'll start looking out for the temperature at specific time, at specific location, am I getting the value or not? The temperature. How? In the back end, it uses some kind of MLDL algorithms. So that means on the historical data, so on the past data, it builds a equation. Okay, and that equation is named as model. Okay, using this model, it is going to predict for the upcoming data. For tomorrow, can I have the temperature today itself? Might be, just as if, for example, two friends are talking to each other. Okay, so what we do when we talk, say, suppose the discussion is happening regarding cricket. Okay, so in the 2 weeks back, we had a final match, Champions Trophy, right? It is between India and New Zealand. So, if you are aware of cricket, anyways, India have won the Champions Trophy 2025, and we have celebrated the victory very well. But if there is a conversation happening between two friends about this particular match, before the match, one friend will ask the question like this: Who is going to win today's match? So the other one will obviously say India, because we being Indians will support India, right? But the other person says no, it will be New Zealand because of the players' consistency, the players' form. Okay, so the friends are giving the predictions, but are they giving the predictions on any proof? No, they're just giving the prediction based on the performance, or they are unable to prove it. They can't prove it. But using any machine learning or deep learning algorithm, I'm going to build my model, right? So this model helps us to predict. I can predict the same output. In this case, either India or New Zealand is going to win. Okay, using a model, and this model can be, I can also explain. So this is how India is going to win, or this is how New Zealand is going to win. So we can explain it. But in our case, we are just predicting randomly, or we are predicting based on our favor. Okay, I'm an Indian, I'll support India, so that is the reason my prediction is India. But that is not generally accepted. So in these cases, wherever you want to do predictions, we use the concepts of artificial intelligence. And the widely used, every one of us is aware. Driverless car? Yes. What does driverless car do? Driverless car is again a car in which there is no driver. That is why it is named as driverless car. Okay, driver is not required to drive a driverless car. See, so when a driverless car is, going on a street, on a lane, okay, if there is an object in front of the car, will it hit the person and draw on it? No. Either it will apply brake, either it will, or it will steer to left or right. If not, it will honk. You know, depending on the situation, it is going to act. But a car, a machine, how it is able to, think and perform upon the situation, it is taking the decision. That is because of AI. We are training a machine. Okay, in the same way, you are training a model. Okay, you are going to build a model, and that model will be trained on historical data. So, friends, historical data refers to past data, history, historical, right? The data that I have till yesterday will be past data. Once after building the model, we'll evaluate that model. Simple, right? See, it's not like you build immediately we go and use it for the new data. No, you have you have to evaluate it. Excuse me. Once after evaluation, if the results are good, if the results are extraordinary, then we'll deploy it. We'll move to the production. So this deployed model will be monitored. So again, it's not like once after the deployment you are done with the project. You'll also do some kind of monitoring. How is the model predicting on the new data? Is it predicting good? So for example, there are 100 patients data with me. Okay, and using this 100 patients data, I have built a model, I have evaluated it, and I have deployed. Now, after the model is in production, okay, it is running the production server. So what I'll do, a new patient walked into the hospital. What I'll do is I'll gather the details, I'll get all the details, okay, of this new patient. Will I also have this y column? No, this y column will be given by our model. Okay, so how are the results? Is it giving right results? Is it promising the accuracy? How accurate the results are? Everything will be monitored. And if the model performance gets down anywhere, we'll start doing some kind of maintenance. That's what we do even for our machines. If you have a bike, if you have any automobile, what you do when you buy initially, you'll use it till they'll mention some up to these kilometers you can use it. Then after some x kilometers, from 500 kilometers or 1000 kilometers, you have to complete your first servicing. The reason is, you know in order to give the best performance by that machine, we'll do some kind of maintenance in the middle. In the same way, we'll do maintenance for our models. Okay, so this will ensure that the model performance will not be down. The performance will be maintained. Okay, so why someone have to understand CRISP-MLQ to the depth is, you should be a position to explain all the 6 steps. Then, as part of third phase, we are learning the concepts of, machine learning, deep learning, all algorithms related to AI. Okay, so as I have discussed earlier, in these sessions, we are going to learn the concepts of machine learning. In this week, we'll be learning the concepts of machine learning. Right. Now, I hope everyone had a good understanding regarding CRISP-MLQ. I'll go back and I'll talk about machine learning. What are the different types of learning that we have under machine learning? Machine learning is broadly classified into three types: unsupervised, supervised, and reinforcement. Am I right? Or do you have anything else? Right. What are these three types of machine learning? Unsupervised learning, supervised learning, reinforcement learning. Unsupervised learning is generally used on or is generally used for you know segmenting, or it is used on unlabeled data. What is this labeled data? Unlabeled data. Labeled data means the data in which we have output. So unlabeled data means the data in which we don't have output. If you don't have output, go and use unsupervised algorithms. Okay, what kind of algorithms we'll have under unsupervised? We'll generally have the algorithms like clustering, dimension reduction, association rules, then recommendation engine. All of these comes under unsupervised friends. Why? There is no output. Output is not present here. You'll have only inputs, nothing but your features. So using those features, you'll segment. You'll create some segments to understand the customer behavior, or in order to reduce the data, we'll perform PCA, SVD. There are n number of algorithms under unsupervised as well. But in the real world, you know, compared to unsupervised, supervised is used in majority of the cases. So supervised algorithms are used on labeled data where you have output. Target. Output is also called as target. Y column that we are talking about, Y column. If your data has both inputs and output, we generally use supervised algorithms. And finally, reinforcement. Reinforcement learning is different, where it gets trained on the rewards. Okay, that is different. I hope we had an good understanding regarding unsupervised and supervised. So in these sessions, I mean, as part of this week, we are going to learn unsupervised algorithms. Okay, so throughout these 6 days, okay, from this Monday till Saturday, both forenoon, afternoon, we'll be learning the concepts of supervised algorithms. Again, the question comes here. Supervised is again classified into two types. Come on, friends, any idea? What are the types that we have under supervised algorithms? Classification, regression. Classification and regression. Yes. So classification algorithms, what are these classification algorithms and what are the regression algorithms? Right. So on what basis does these supervised algorithms are divided into two parts is based on Y. Whatever the values that you have under the Y column, based on those values, you know, we are supposed to fix whether we are going to use a classification algorithm or regression algorithm. How? If your Y values in your Y column, if the values are discrete, what do you mean by discrete actually? My friend, again, we we understood this particular topic as part of Python 2 AI sessions, 30 days Python 2 AI sessions. So if you missed those sessions, again, those sessions are like fundamentals. Go and just have an understanding regarding all these basics. Discrete represents fixed fixed values. Examples, pass, fail, cancer, no cancer. You'll have fixed values as part of your y. Okay, so if you have discrete values in your y column, we use classification algorithms. If not, if you have continuous values as part of y column, we use regression algorithms. Continuous, yes, the values which can be represented to any extent. So the range of continuous data will be from minus infinity to plus infinity. Predicting price of a stock. Okay, so I hope everyone is aware of stocks, shares, right? So if you take stocks, who is predicting it? Who is predicting the price of a stock? There is an XYZ company. If you take some XYZ company, what is the price of stock? How you are able to predict? I'll use a regression algorithm. Using the regression algorithm, I can predict the price of a stock. The reason is it will be a number. See, if you talk about price, can it be fixed? No. It should be a number 100.19. Can it be fixed? No. Today it might be fixed, but for tomorrow it will change. So that is how stocks require a lot of knowledge before you invest. Right? So in the back end, some regression algorithms will be used. If not, predicting price of a house. So depending on some XYZ features, I can predict, right? So in session, forenoon sessions, we are going to learn classification algorithms. And in the afternoon sessions, we'll understand regression algorithms. I hope you have a clear understanding here. If not, ask me the questions now itself. Is it clear so far? So in this week, we'll learn only supervised algorithms. Whatever algorithm that we learn, we'll also come up with a project. We'll come up with a project. Okay. So in the forenoon sessions, we'll learn complete classification algorithms, and in the afternoon sessions, we'll complete regression algorithms. So friends, hope everyone have a clear understanding till this point. Okay, so now the question comes, what are the different classification algorithms that we have? What are the different classification algorithms that we have? Again, before I talk about the classification algorithms, I'll talk about classification types. Classification is again divided into binary classification. So what exactly do you mean by binary classification? Come on, friends. At least, if you have a knowledge about this particular word, binary classification, you can respond. See, not every time will be correct, but give a try so that we can make the class interactive. Right? So, what do you mean by binary classification? Binary classification, yes, means, if you have two classes, it represents binary classification. Example, all of these are example, friends. Examples, you see, pass, column, I'll have only two classes. One is pass, the other classes I will not have any other third class. That is called, binary classification. Okay, we are going to classify pass class and fail class. Then default, not default. So banking sector, whether a person will, repay the amount or not. All of us will take loans. So before we take loans, we can also study the person's behavior. Okay, by taking different features into the consideration, I can understand whether that particular person will default or not default, whether he'll pay or not pay. Okay, in the same way, the second thing, the second type is talking about multi-class. Binary classification is clear. The second type is multi-classification. So what does multi-classification means? Example, simple. If you have two classes, it means binary classification. If you have more than two, that's it. It is multiple class. So more than two can be 3, 4, 10, 100, whatever might be the number, it comes under multi-classification only. Okay, it comes under multi-classification. So we have lot of examples. Okay, so wherever you have more than two classes under your Y column, it comes under multi-classification. Okay, for example, classifying types of car. If you take cars, if you have the data with respect to all the cars, so we have types under cars. We'll have mini, then we have sedan, we have SUVs. Okay, so in order to classify them, we are supposed to use multi-classification, because here the classes are more than two. Okay, if you have more than two classes, it comes under multi-classification. Then, can you guess what will be the third type? Any one of you? If you have any knowledge on machine learning, especially regarding classification algorithms, any idea regarding the third type? Multi-label. There is a lot of difference between multi-class, multi-label. Multi-class represents in your Y column, if you have more than two classes, it comes under multi-classification. But multi-label classification represents each and every instance, okay, will be decided on multiple features. Each and every row, for example, if you take movies, okay, so there is some XYZ movie. For example, I take Triple R. In order to talk about Triple R, is it a romantic movie? No. It's not about romance that we talk about Triple R. Is it an action movie? Yes. Is it a horror movie? No. Okay. So if you talk about any specific movie, this is generally the best example that I give for multi-label classification. Each and every instance will have multiple labels. It will be explained by multiple labels. Drama, yes. So I just took it as an example. So using some multiple labels, you are going to explain that instance. That comes under multi-label classification. Okay, so these are the different types of classification we have. How we can classify different types of data is binary, multiple class, and multi-label. Okay, so classification algorithms that we generally use in the market, that are widely used, are Bayes. Okay, it is Bayes algorithm. So the current topic that we are going to learn, this is widely used. Then the next one is KNN, K nearest neighbors. Okay, this is one of the algorithm that we learn under classification. And friends, this is already covered as part of the 30 days, short-term training from Python to AI. Okay, so if you have missed, again, you are supposed to go and complete this particular algorithm as part of these sessions. KNN was already covered. We understood an example as well. Okay, as part of the sessions, we have understood an example. Then also we have covered a project. Project is also explained, including deployment, right? And finally, DT, decision tree, neighbors, K nearest neighbors, decision tree. These three are widely used for classification problems. Okay, whenever you want to classify, there is a classification problem, you know, these three algorithms comes into the picture. These three algorithms are also called as shallow techniques. These are called as shallow techniques. Why they are named as shallow techniques is these three algorithms can also be used for regression. Akhil, I did not understand. Can you go back? Yes. Friends, what did we discuss? We discussed that naive KNN decision tree are widely used algorithms for classification problems. Okay, that means if the values under the y column, if they are okay, if they are discrete, fixed, either it is 2 class, 3 class, whatever it might be, we are not worried. Okay, if it is just a classification problem, we can use any one of these three, or we can try all the three. Okay, and these are widely used is what we have understood. But are these three algorithms can be used for regression as well? Yes. Yes. Okay, so but we'll understand these three algorithms with respect to classification, my friends, because with regression I'm going to talk about, you're going to understand different algorithms, okay, in the afternoon session. Okay, so what algorithms will be covered, okay, how they are going to, how are we going to apply as part of the real time, everything we'll understand as part of regression. I'll not touch about regression in the forenoon sessions. Okay, I hope it's very clear. So as part of this week, okay, the module 1, machine learning with respect to the classification algorithms, we are going to learn naive Bayes and decision tree with project. With project. If the time permits, we'll also deploy the project. We'll deploy it. Okay, but Akhil, you may ask, Akhil, why you are not teaching KNN? Friends, this was already covered as part of short-term training from Python to AI. So if you have missed, go and watch that particular video. Okay, right. Now let us understand what is naive Bayes. We'll understand naive Bayes. I'll also give a small example how naive Bayes is used for classification problems. Naive Bayes, you know, this naive Bayes algorithm, it works completely on the concept of probability. It works on the concept of probability. Oh my God. Akhil, are you going to teach again math? No, friends. We are just going to revise the concepts of basic mathematics. If you have good amount of knowledge on math, you need not struggle in understanding the algorithms. And moreover, especially for machine learning and deep learning algorithms, together for AI, it is always suggested if you have good amount of knowledge on mathematics. Okay, not on all the topics, topics like probability, matrices, then optimization, okay, differentiation. So if you have knowledge on these topics, that is enough, as well as linear algebra. Okay, so these topics, if you have good amount of knowledge, it is more than enough. Beyond these topics, it is not required, because majority of the algorithms use math inside it. Okay, as part of each and every algorithm, it uses math. Any one of the topic, a combination of all the topics also can be possible, right? So naive Bayes uses probability concepts. So let's explore how this naive Bayes is going to use the concepts of probability. Okay, so what we are going to understand, we are going to start with introduction part, then the probability concept, what is probability, what are the conditions, the properties of probability. Okay, then we'll talk about a special type of probability called conditional probability. Okay, followed by Bayes theorem, a very important theorem. Based on Bayes theorem only, naive Bayes algorithms. Okay, what are the different types of naive Bayes we have, or what are the different types of naive Bayes we generally use as part of the projects, we'll discuss. And finally, a small use case we'll understand as part of the theory part, and finally the applications. Okay, so we'll talk about these. Post completing these topics, we'll go and you know understand whatever we have project, right? So a supervised learning, supervised, which is generally used for classification. The general purpose of naive Bayes algorithm is to classify data, nothing but performing classification. Again, actually, will it classify binary or multi class? No, irrespective of the type, we can go and use. The term naive actually refers the classifier. It assumes that the input features, whatever the input features that we have, x1, x2, x3, so on, xn, it assumes that all of these features are independent of each other. So that features should not be depending on each other. So this is the general assumptions that Bayes algorithm has. Okay, so that even if one of the input change, it is not affecting the others, right? That is the basic assumption that naive Bayes has. And here is the formula for the Bayes theorem. Okay, so what is this? This is called as posterior probability, and this is called prior probability, and this is called marginality. I'll talk about this. How we are going to achieve this formula also will derive in class. Okay, but this is very, very, very important formula. The main reason, when you work on any project with respect to naive Bayes, and if you mention it as part of your resume, for sure you can expect this question from the interviewers, if you are a fresher or an intermediate person who has basic experience. Okay, so this is very important formula. Posterior probability is equals to likelihood multiplied by prior probability by evidence or nothing but marginal probability. Okay, how we are going to achieve this formula, we'll understand, no worries, we'll derive it in the class. If not today, might be in the tomorrow's section at least, we'll understand. Okay, then we'll proceed, right? So we know that naive Bayes, it uses the concepts of probability. Yes, naive. Okay, so we should have on probability first. So let us understand what exactly is probability. So friends, before I explain, if you have any knowledge on probability, what do you mean by probability? Answer them in the chat. Use you can answer the question. What exactly is probability? No one. So this is the major for majority of us. This is the toughest subject, toughest topic as part of math. I believe, because even I used to feel the same, right? So let us not feel the same, but try to understand the concept of probability. It is very simple, right? So probability is generally represented as interested events divided by total number of outcomes, right? So this probability helps us to talk about the likelihood of an event occurring. Okay, interested events, when you toss a coin, okay, you'll get either head or tail. Okay, what you are interested for, what is your interested event? Okay, when you toss a coin, what is the probability of getting a head? It is 1 by 2. Why? Because the total number of outcomes are 2. Either I can get a head or tail. But what you are interested in? I'm interested in getting only head. So when you toss the coin, one coin will have only one head. I'm talking about an unbiased coin, a fair coin. If you take a fair coin, it has a head and tail. So when you toss it, you can get only one head. So the interested event will take one, and the total sample space is nothing but two, right? So this is how we represent probability. In simple, when someone asks you the question regarding probability, how do you define probability, I'll simply make my statement like this: interested events by total number of outcomes. In the same way, for a dice, if you roll a dice, you know probably how many outcomes can be expected? Six. Total number of outcomes are six. You can get 1, 2, 3, 4, 5, 6. Any number can be achieved. But what you're interested in, my interest is to get one. So probably you'll get only one. There is only event happening for once. If not, what is the probability of getting two when I roll a die for single time, for once? Will it be 2 by 6? No. Will it be 1 by 6 only, friends? Sample space will be 6 again. But how many times you can get 2 when you roll once? Probably once only. It cannot be 2. This one is representing interested events. Right? So the probability of all the numbers will be 1 by 6 when you roll a die for once. And if you talk about the properties of probability, always probability lies between 0 and 1. So that means probability of any event cannot be, you know, it cannot be greater than 1, and it cannot be less than 0. Am I right? Yes. Can it be 0? Yes. Can it be 1? Yes. Okay. It can be 1, it can be 0 also. But it cannot be less than 0, it cannot be greater than 1. Right? So what does 0 represent is, again, that particular event does not happen, and 1 represents that event will happen for sure. Okay, so this is how we generally understand the concept of probability. There are n number of use cases where we use probability. This is very important topic, right? So probability seems a tough topic. No, it's not exactly. When you do enough topic, you'll get good. And there is one more property of probability, friends. Summation of all the probabilities with will be 1. I did not get this point again. I'll talk. I'll talk about the first probability. If you The probability of getting head when you toss a coin for once is 1 by 2. 1 by 2 is nothing but 0.5. 0.5. So is it greater than 1? No. Is it less than 0? No. So is it lying between 0 and 1? Yes. So properties should match. Then coming to the next property, summation of all the properties with respect to an event will be 1. The probability of getting head is 0.5. Okay. Then probability of getting tail is also 0.5 only. Okay. So when you do summation, when you add all the probabilities, you have to get 1. So 0.5 plus 0.5, it is 1. That is what the second property talks about. Two important properties. First, understand what is probability, the formula for probability, understand with an example, then the properties. Enough. Okay. Right. Then comes probability. This is a type of probability, but conditional probability is generally calculated for 2 or more than 2 events. Okay, so if you have 2 or more than 2 events, only then conditional probability can be calculated. What is this conditional probability? We'll understand. Assume there are 2 events. I'm going to take an example and I'm explaining the concept of conditional probability. Okay, so there are 2 events A and B. Using these 2 events, let us understand the definition of conditional probability. Conditional probability of event B is defined as the probability that event B will occur given the knowledge that event A has already occurred. So it means based on a condition. What is the rule? In order to happen, event B happen, it A is already happened. That is where conditional probability comes into the picture, and it is given as P of B slash representing P probability of B given A. That means in order to happen the event B, event A should already occur, is what it means. You should not represent this slash as, you should not read it as slash, you should read it as probability of B given A. That means A event should already happen in order to occur event B. And this is mathematic given with this formula. P of probability of A and B divided by probability of A. Anyhow, you'll know the probability of A. How? Because event A has already happened, right? Once the event A has happened, you'll get the probability of A. Then you can also get the probability of A and B. Once if you get these two, you can get the conditional probability B given A. Okay, so we had a small example. We'll use this formula of conditional probability and understand a small example. Every one of us are aware of playing cards. Yes, all of us are aware of playing cards. Might be. There might be some exceptions. A few of us will not be aware of playing cards as well, but I'll take an example regarding playing cards. So playing cards, if you take a deck, there are 52 cards, my friends. Okay, I'm aware of playing cards. Okay, I'll play generally, but no, that's not the right time to discuss all these things. Anyways, so we have 52 cards in a deck. When you take a pack of cards, there are 52. These 52 cards are made into two categories based on color: red, black. Am I right? So, friends, if you are aware, correct me if I'm wrong. Okay. These 52 cards are made into two, they are divided into two parts. One is based on color, red and black. Yes. So each part, each portion will have 26, 26. Because 26 plus 26 is 52. Done. Then this again, these two parts are divided into two subparts again. So I can keep like this: 52 cards are made into four parts. Four. Based on, you see the symbol? Based on this symbol, they are made into four parts. One is called diamond, spade, and club. Okay, four different shapes for the cards. So it means there are 13 cards with heart symbol, 13 cards with diamond symbol, 13 cards with spade, and 13 cards with, yes, 13 cards with club. Okay, so all these four together represents 52. Okay, why am I explaining this is, if you don't have any knowledge on playing cards, you will not understand this question. Okay, so that is the reason I'm explaining. Now I'll talk about each and every 13 cards. These 13 cards are numbered, friends, from ace till king. Okay, I'll talk about 2, 3, so on, jack, queen, king. How many cards? 13. 1, 2, 3, 4, so on, 10. So these are 10 cards. Jack will be 11, queen will be 12, 13. 13, yes, satisfied. Okay, what does this mean? For each and every 13 card, you'll have numbers. I mean, this 13 will be repeated. But what will be changing? The symbol will be changing. Okay, the symbol change. Right? Is it clear till here? Now let us understand the question. There is a standard deck of 52 cards, playing cards, and we want to calculate the probability of drawing a queen. Drawing a queen, and this queen, drawing a queen is, I want to represent as event B. Okay, first of all, how many queens can you have in 52 cards? 1, 1, 1, 1. So how many queens? 4 queens. Are these the 4? Akhil, how can you tell that these are the 4 queens? Shape. Or in all the 4 shapes, you'll have only 4 queens. Yes. Given that already drawn card is diamond. Diamond represents drawing a diamond card. Okay. So you are supposed to calculate the probability, conditional probability. So P of given A has to be calculated. P of nothing but this formula, P of A and B divided by P of A. So that means first I have to calculate P of A. What is the probability of A? P of A represents drawing a diamond card. How many diamond cards will have? 13. Am I right? So in 52 cards, how many diamond cards I'll have? 13. So interested outcomes are 13. But sample space is 52. Right? So total number of outcomes are 52. Out of them, I should draw only a diamond card. How many chances do I have? 13. So it will be 1 by 4. I got the value for P of A. It is 1 by 4. Then, what else to be calculated? I should also go and calculate P of A and B. I should go and calculate P of A and B. P of A and B, yes, I'll not remove anything. Focus. P of A and B is calculated using, see, the same Okay, we should ensure that, and it should be a queen. How many such cards exist in a pack of deck, in a playing card? It is only one. It will be only one out of 52 cards. Only a single queen diamond card will exist out of 52 cards. So the number of interested events will be 1, and the total sample space is 52. So we also got P of A and B, and you can substitute the values in the formula. 1 by 52 divided by 13 by 52. 52 gets cancelled and you'll get 1 by 13. So this is the probability of drawing a queen given that the card drawn is diamond. It's 1 by 13. Okay. We understand the concept of conditional. Why should we learn conditional probability is using the concept of conditional probability, we'll draw a Bayes theorem. Okay, this Bayes theorem is used internally by Naive-Bayes algorithm. Naive-Bayes algorithm uses the concept of Bayes theorem. Okay, so till here, just go through a few more examples with respect to conditional probability. Tomorrow, the same time, we'll understand Bayes theorem and an application for Naive-Bayes algorithm. We'll take a small use case, how it can be done. Everything we'll understand in tomorrow's session, because it's already, I have delayed it anyhow. Okay, so I'll talk about next topics in the next class. I'll talk about the types, use case, how we are going to derive it, what exactly happens in the backend, how Naive-Bayes is able to predict the probability. Okay, how it is able to classify. We'll discuss in the tomorrow session, as well as the Laplace estimator. Okay, and finally the applications. Yes, Bayes theorem. So I'll stop the session here, and it's time for your questions. Thank you. Thank you so much. So friends, just also share across your, connections. Ask them to join these sessions. The reason is, in this current market, majority of the interviewers, they are looking out for the skills regarding machine learning, deep learning, okay, generative AI. So these sessions are related to those particular, skills. So whoever is looking out for the similar kind of skills, ask them to join these sessions and get benefited, right? So the feedback link has been provided. Before you leave, give your valuable feedback, and you're free to leave. Until unless if you don't have any question. Again, before you leave, my sincere request is, hit on the like button if you like, if you feel that these sessions are great, interactive, and if you get good amount of knowledge, hit on the like button, and also add some kind of comments. At the end, add some comments, ask your questions via comments, and also share across your connections. And if you haven't subscribed to our channel, do subscribe it as well, right? So that's all for the day. Again, we'll connect in the same time tomorrow, and we'll continue our discussion. Until then, take care. Have a great day. Signing off.